We have 5 people absent, so I'm going to record. This is more sort of analyzing graphs. This time we are going to be looking at if a graph is increasing, decreasing, constant, if it has like a maximum value or a minimum value. And there's 2 types of maximums and minimums. There's like an absolute maximum, which is a graph like this one reaches this maximum height and never goes any higher. And sometimes there's what's called a relative maximum, where if you have a graph that kind of does this, you know, up here would be the, up here would be the absolute maximum, but this is a relative maximum because in that little interval it reaches a height which is significant. So those are really the things that we're going to be talking about today. A lot of this work is done on the graphing calculator, so if you could take your graphing calculator out, you're going to need it. So this particular graph, I think it's kind of self-explanatory, right? This is increasing. Constant is if it's just a flat line, basically, for every x in that interval. It's the same y. It's constant. And then the decreasing is here, obviously. So if we look at this graph, and we look for the intervals where it's increasing, you have to name all the intervals where it's increasing. So you're going to have some U's in here, some unions, if there's more than one place that it's increasing and decreasing and constant. The thing you want to realize is that you're not going to use brackets ever if there's a question about increasing, decreasing, or constant. Because at those endpoints, you're really not seeing that behavior anymore, right? It's not increasing at that point. So that's why we're always going to use parentheses, even with our interval notation, even when it's a solid dot, right? Okay, so increasing in this case, we're going to assume these are counting by ones. So 1, 2, 3, 4. Here's the 5. Increasing, if we're going from left to right, the first interval that it's increasing is this right here. So that's from -5 to -3. And we're just going to write it like this. That's interval notation. Now, when is it increasing again? Yep, Nathan. -1 to 1. Good. That's another spot where it's increasing. So we're going to put union -1 to 1. Now, is it ever increasing again? Yeah, Quinn? Yep. From here to here is another increasing interval. So union 4 to 5. Now, where is it decreasing? Again, we're reading from left to right, so we start here. It's decreasing here. Notice this arrow on the end here means that it's coming forever, right? So it's from -infinity up until this -5 point. That's decreasing. Is it decreasing again? Yep, May. So from 1 to 4, it's decreasing again. So union 1 to 4. And now the last thing is constant. And those are just the flat lines. And that's really just going to fill in the spots we haven't talked about yet. So between -3 and -1. And then from, what are we at, 5? 1, 2, 3, 4, yeah, 5 to infinity. That make sense? So then if we talk about extrema on the next page, I'll just show those answers on the video really quickly. Okay, extrema, that's the extremes of the graph, right? So this is going to be maximums and minimums. Somebody asked me an individual question, and I related this to like if you were on a roller coaster, right? You're coming from the left, and you're on a roller coaster, and you are going down on the roller coaster first. That's decreasing. Then you go up a hill. That's increasing. Then you flatten out, right? So if you think about it kind of like a roller coaster, same thing with these extrema, right? Whenever you kind of reach a point where you're switching from increasing to decreasing, that's a maximum, right? And then when you, so here's a maximum, and then you dip back down, and then you reach a point where you're switching from decreasing to increasing, that's a minimum. And even though this next one right here isn't the highest you've been on that roller coaster so far, it's still a significant turning point, right? It's still switching from increasing to decreasing, so that's a relative maximum. When you look at the whole graph, when as a whole, this is a relative maximum, this is a relative maximum. Why is this not an absolute maximum, this one right here? Because it goes infinitely up. I would not want to be on this roller coaster. I'm never going to get off. But right, when you see the arrows, then there's going to be no absolute maximum or absolute minimum, because it goes forever up and forever down. But it's significant to talk about these turning points as relative maximums or minimums. All right. There's a little explanation there. Okay, this is where your skill of reading graphs is going to be important. Here they have the graphs for you. They give you the equation, right? It's kind of a complicated equation, and you have to just read the graph. Eventually, on the next page, you're going to be programming these types of equations into your calculator and then reading them off your calculator. So that's why you need your calculator for this. Okay, so in this case, this first graph here, let me call it graph A, is that a, does that have a absolute maximum? No, there's no absolute maximum. Does it have an absolute minimum? No. Okay, does it have a relative maximum? Yes, okay. Here's your relative maximum. We're going to just give the point for that maximum. Here they're counting by 2's on this interval, on the x interval, x-axis. So this is at 2, and it reaches up again. Are they counting by 2's on the y? No, they're counting by 4's, so we got to be careful here. This is 4, 8, 12, 16. So this looks like it's going to be about maybe 15, 14. It doesn't look like it's halfway. I've put too much on there. Yeah, it looks more like halfway between the 14 and the 12 and the 16, so that's going to be a 14. So it looks like we're at 2, 14. And do you see a relative minimum? Yep, here's a relative minimum right here. So that's going to be when x is, looks like -1, and then we go down to -8. So just be careful reading your graphs and noticing what they're counting by. Okay, so absolute maximum is here. That's the highest point the whole graph reaches ever. Relative maximum is here because that is a high point in the graph, but not the highest point. And then the relative minimum is going to be here. So we need a ordered pair for that. What'd you get for that one? Buddy, what'd you get? Okay, so yeah, I mean, if you guessed 1, that's okay. Be careful on the negative one, though, because in the y direction, they're counting by 4s. So 1, -4, that's an okay guess. If you want it to be a little more precise, it looks like more like 0.8 or something ridiculous like that, but that's okay. All right, and then this last one, you guys try that one on your own. Any questions on that last one? Okay. So now it's when you need your graphing calculator. All right, so if we this thing is so huge. So if we do this first one here, we're going to plug this equation into our calculator. Well, that's helpful. And the way you want to do that, if you forgot, you're going to go to y equals. And then you're just entering exactly what you see. This is your x button right here. And then to the is the little caret, 4th. And then minus x again. And even if they have, you know, t or y, I mean not y, but q or r or p, it doesn't matter what your variable is, you're still using that same, oops, sorry, this calculator works differently than the one I have that I hold in my hand, so I'm just going to start that again. Be careful. Oops. Okay. This is a good video, by the way. Really, really good. Okay, so y equals, be careful, I don't know if yours does what that one just did, but when I went to the 4th, it kept everything up there. That's not how mine works on the one that I use in my hand. So you have to get this arrow here to be back down to the regular. So if you just push the right arrow, it'll be back down to where it belongs, right? Minus, and then x squared. Again, get that back down. Oh, it's already back down. Minus 2x plus 4. Okay, now you want to go to graph it. Here's the thing, you have to pay close attention to your window. Now this graph turned up okay for me on my regular window. Did anybody have a problem where their graph didn't show up? Yes? Okay, so you might have to adjust your window. So here's your window button. Notice in my window button, my x minimum is at -10. Does everybody understand what this window does? Right? Think of it as if I handed you an actual physical piece of graph paper and said graph this. You would have to put your axes on that graph paper and decide what am I going to count by, and what is my lowest, and what's my highest going to be on my x and on my y, right? So that's what this screen is telling you. The x minimum is to the left, how far, x maximum is to the right, how far, x scale is what you're going to count by, etc. So if your graph didn't actually show up, sometimes you have to adjust your window so that it appears in the window that you're looking at. Okay, judging by this graph, is there a relative maximum? No, looks like it goes forever up on both sides, right? So no relative maximum. Is there a, I'm sorry, I meant absolute maximum. Is there a absolute minimum? Yes, this definitely reaches a low point. So what does it look like that low point is? It looks like 1, 2. But sometimes you're not going to be able to tell exactly what it is. So your calculator can show you. Does anybody remember how to do this? Yes? Okay, go. Yep, okay, so you're going to do second button, and then the trace button, which is calc. Right, so then go to minimum. You can either scroll down or push the 3. And now it's asking you left bound, and it's going to ask you right bound. So if you look, it has a little cursor blinking on the screen here and saying, is this, it's asking you, is this to the left of the minimum you're trying to find? And is that to the left of the minimum we're trying to find? Yes. So we're going to push enter. And now it's asking us right bound. Well, is that blinking cursor actually to the right of the minimum? No, we have to move it. So we're going to use our arrows, and we're going to move it over till it is to the right of the minimum we're trying to find. I went a little too far, but that's okay. And enter. Now it's saying, do you want me to guess? Yes, please. That's why we're doing this, right? And then you push enter. And it's showing you the minimum is 0.9999. That's close enough to 1, right? So 1, 2 was a good guess for that absolute minimum. Does that make sense? Okay. So absolute maximum, none. Absolute minimum, 1, 2. Was there a relative max? No. Is there a relative min? No. Remember, maximum or a minimum is a place where you're changing from increasing to decreasing or decreasing to increasing. This little blip right here kind of does a little whoop. It doesn't really, it's still decreasing. So that doesn't count as a relative maximum or minimum. So none. Now, if we want to talk about increasing, decreasing, or constant, what would be the decreasing? From where to where is decreasing? Yep. Negative infinity to 1. Right? Because you're going this direction, right? Negative infinity on the x's until you get to x is 1. That's where it is decreasing. So decreasing is negative infinity to 1. Increasing would be from 1 to infinity, and constant is none. Okay, so if we look at this next one, some people were saying it's so hard to see, like, details of where that is. We could change our window to zoom in a little bit. I put my marker down. Right? If we want to zoom in a little bit, let's go from -5 to 5. And let's go from actually -5 might not do it. Did it? Yeah, maybe it did. -5 to 5 again. So we can see it a little bit closer now. And so then when we do our left bound, right bound kind of thing, we can see a little better. So let's do second trace, and let's do a minimum first. And left bound, yes. Right bound, yes. And then guess. It comes out to 1.2 and negative 1.1. Okay, so if you do that and you zoom in, you'll get a little bit more of a accurate. All right. Increasing, I have from 1.2 to 2. Decreasing from negative infinity to 1.2. And then again from 2 to infinity. And constant never. Okay, so that's going to translate into some real life situations, which is another way of saying word problems. Nobody likes it when I say word problems, so we'll just say real life situations. Right? So sometimes you have a situation where you want to maximize, often, your profit, right? If you have a company and you produce whatever it is, you want to maximize your profit. You might think, well, the more you make, the more of these items you make, the more money you'll make. But is that always true? I mean, you could make too many. If there's too many out there, that means you've spent money making lots of stuff, and maybe there's not enough people buying it. So there is a point where you're going to kind of break even, and there's a point where you are going to maximize your profit, and you don't want to kind of go over that. So this is a situation where they are computer company, new processor chip. This is the profit equation that they've come up with, where X is the sales price of the chip in hundreds of dollars. What is the optimum price per chip? So what we need to do is put this graph again into our calculator and find the maximum, because the maximum will give us the optimum price per chip. When we do this, it turns out the relative max is at the point 448, right? So what is the optimum price per chip? $4. And what profit? What is the profit at that price? $48. So this is how those graphs translate to real life. No, because they're telling you at that price point, your profit will be $48. Yeah. Yes. 448 is the max. And so the price per chip that's maximizes your profit is the $4. Yeah. Okay. I'm going to skip because we're running out of time, and I'm going to skip to this height of an object. I think you've done these. Have you done this before last year? Right? This is a really common, quadratic type of word problem. This is a formula. The height of an object at time t is negative 16t squared plus 30t plus 4. Well, that's this particular situation. But the plus 4 is, it's going from a height of 4. In other words, like maybe I'm taking the ball and throwing it from 4 feet off the ground. And it's going to follow sort of a parabolic path. So it can be illustrated as a quadratic equation. This negative 16t squared, that's the thing that's always the same when you're talking about a thrown object. The other things change based on the situation. But they're telling you this. What you want to do is put it into your calculator, again, and read the graph on your calculator. They're asking you increasing, decreasing in this case, but the significant question here is how long does it take for the object to reach the maximum height? And what is the maximum height? So again, we're just going to use our graphing calculator. We're going to put this equation in, and we're going to read the increasing, decreasing, constant. Well, it's not going to be constant because the ball wouldn't do that in the air, right? And relative maximum, absolute maximum in this case.